This is the beginning of section 3.4, day 2. And yesterday we talked about the log properties. We're going to use some of those log properties to accomplish various things throughout the different examples here today. One of those examples is transformations. Now we're going to do transformations from the graph y equals ln of x. Now, when we're talking transformations for log functions, usually what we have to do is consider the same base for the transformation. So if we're going to do ln for the parent function, we need to have an ln in the other function, the transformed functions. But we don't have that here. And so that's part of what we're going to do first off to just figure out what the transformations are for these two examples. So we're going to use the change of base formula in order to accomplish that. Now, since we want ln as the parent function, when we use the change of base here, we're going to specifically pick the ln version of it. So that would look like ln of x minus 2 divided by ln 7. All right, so that way we have ln's in here. We're going to be splitting this up with ln's, and that way we won't have to worry about the base. Now, as far as transformations go, all the different positions remain the same, the way that we do the transformations, and so it would be good to get this into a form that is more compatible with transformations. This ln7 specifically, it's on the denominator, so dividing by ln7 is the same thing as multiplying by 1 over ln7. I'm just pulling that out to the front because that way it's just like multiplying the whole function, and then we can get some vertical stretch or shrink depending on what that number is worth. And then we leave this stuff out here. Now we have this in a form that can more easily be looked at with transformations. We'll start with what's on the inside here, x minus 2. That means one of my transformations, the first one, is right 2. Now the second one has to do with multiplying by 1 over ln7. I don't know necessarily what that is right off the bat, so I'm just going to calculate that and just do 1 divided by ln7 just to see what that number is. So that number is about 0.51, which means it's less than 1, which means that we're talking about a vertical shrink in this case. So we're going to say that this is a vertical shrink by a factor of whatever this is. Now, since we want to just be as exact as possible, I'm just going to put by the factor of 1 over ln7, and that takes care of the two transformations for this one. So we're going to be doing that same thing down here as well. Let's take a look at that one. It says that we have a little bit different situation now. For the second example, we have log base 1/5 of x plus 4. And that 1/5 is something that we actually looked at in one of the last examples yesterday. So we're going to do the same formula, just the exact same start to this problem. We're going to go ln of x plus 4 over ln of, where was it? 1/5. Okay. Now here's the trick that we learned yesterday about this one. If we have got this 1/5, we're going to represent that a little bit differently. We're going to put that in as a negative exponent expression. And so 1/5 is the same as 5 to the negative 1. Now, if you remember from yesterday, what that did is that means we can move that negative out in front, rewrite this as negative ln of 5 on the bottom. So we've got negative ln 5 on the bottom. All right, so now we'll treat this one much like we did up here with that first example, and we'll split this up. So I'm going to split this up again, divided by negative ln 5. That's the same as multiplying by the fraction of 1 over ln 5. Now I'm going to put the negative out in front so that's easier to look at the transformations here in a second. 1 over ln 5, negative of that, times ln of x plus 4. Now we have it in a form where we can look at the transformations here one by one. Kind of like last time, we're going to start with what's inside here for the horizontal transformations. And so it looks like we're going to have left 4 in this case. Next, we go out here and we've got this 1 over ln 5. We've got the negative. Doesn't matter what order we do those in, but that negative, let's start with that just because that's pretty straightforward. That is a reflection over the x-axis. And then there's one more transformation here, like I mentioned, that 1 over ln 5. Now, we're probably expecting it to be less than 1 because of our previous example, but just check it to make sure. 1 over ln 5 is 0.62. So yes, that one is also a vertical shrink. So a vertical shrink by a factor of 1 over ln 5. So again, transformations can occur on any function we work with, and these are just a couple examples of transformations on log graphs.